So in continuation of our lesson about dilutions, here's some sample questions we can go through.
Yanko has used a 1 mole per liter solution of sodium hydroxide to make 500 mils of a 0.1 mole solution. So if I extract the data, 1 mole is the initial we had, concentration, so C1, 500 milliliters of our diluted solution, so that's V2, and this is C2. So this is the formula we're trying to work out here. What is V1? Now V1 is equal to C2, which is 0.1. I need to convert V2 from milliliters into liters. And I can write that as 500 times 10 to minus 3 or 0.5 liters. Means the same thing. Okay? Times minus 3 equals, or over, sorry, 1. So if you plug that into your calculator, have a look at what answer you get there. .05 liters. Okay, so around about, if I had that in milliliters, that's around about 5 milliliters I had initially. Now if I move on to example 2, with Nathuli trying to make a dilute solution of sulfuric acid, calculate the volume required. Okay, so here we go here. So we have from a concentration of originally this, so that's C1, let's call that. We make up a concentration of 2.5, so that's C2, and that is V2. So what volume do we have? We're using the exact same formula as we used just then, so it's V1 equals to C2 over V2 equals to concentration there. How did I do that? Well, let me show you. C1 V1 equals to C2 V2. I want to move C1 over to this side so I can get V1, leads me to here. Okay? So C2 is 2.5 times 5 liters over 18 moles per liter. So as you can see, these are really just rearranging formula and substituting it into formula type questions. 69, if you look at it, 5.0 and 2.5, 2 sig figs is the lowest we go, so 0.9 or 0.69 liters is the answer. Question 3, it says calculate the concentration of the diluted battery. So I know if it's diluted, I'm going to be using C2. So that's where the hint at the top came from. C1 V1 equals to V2. So C1, what do we have? C1, 4.5. So 4.5 moles per liter times our volume, 5 milliliters. So 5 milliliters is the same thing as saying 5 times 10 to the minus 3 liters. Last bit is to work out what V2 is. V2 is given in the question as 100 milliliters. Again, I need to convert that into liters, so it's 100 times 10 to the minus 3. So 4.5 times 5 times 10 to minus 3 over 100 of that. So I get an answer of 0.225 moles per liter. If I just check with significant figures, all these are in 3 sig figs, so I'll leave it in 3 significant figures as well. which is exactly the same thing as what I got on the answers originally. Okay. Next one we'll move on to is just a couple of other additional calculation questions. So please have a go at these calculations. This time we have concentration of 84.1 grams over 100 milliliters and diluted to 500 milliliters. So what you'll need to do is you can either work this out in terms of milliliters, or you can convert all these values into liters. And in question 5, it says, to what volume should 50 milliliters of this solution of potassium nitrate be diluted to make 0.3 moles of that? Okay. I'm going to go through the answers, or I'm going to shift to the answers very soon. Could you please pause if you want to have a go at the question? So I'm going to move over in 5 seconds. And moving across. So what I did here was I converted my grams from 100 milliliters to grams per liter. So if you think about it, in 1 liter, there is 10 100 milliliters. So if I want to make 100 milliliters into a liter, okay, add it on, that's just 10 extra steps. So I pour 10 100 milliliter of this concentration at 84.1 grams. I get 841 grams per liter. So essentially that's why I times it by 10 there. Also, I made sure everything else is converted into liters, so I substitute that into my formula there. I get an answer of 42 grams per liter. Question 5 is a little bit more straightforward. You don't have to try and do any conversions besides the one for volume. And so just plug it into the formula, and I find that my volume is 0.25 liters. Okay, next we have the summary notes of the chapter. So molarity of a solution is the number of moles of solute per liter. So moles per liter is the unit. Solution in which the concentration is accurately known are called standard solutions. When solutions are diluted, the amount of solute in the diluted solution is the same as it was in the volume of the original solution that was taken. So if I put that down in terms of formulas that we've come across, okay, so molarity, the molarity formula says that it's moles per liter, and for dilution, whatever N1 was, N2 after dilution is the same as that. And so that's basically it for this lesson. So thank you for listening this far if you have. If not, then let me know how else we can improve this video. Until